Hi everyone, today we are going to go through International GCSE Edexcel Chemistry Paper 2 Predicted Paper for 2024. Please still revise every topic since no one can know what will come up on the day. Also subscribe for more predicted paper for chemistry, bio, and math, A-Level, and GCSE. And I put the timestamps in the description if you want to go over specific topics as well as access to the PDF copy. Let's get started. Question 1. Iron is a metal with many uses. One problem with using iron is that it rusts. Name two substances that is needed for iron to rust. This is oxygen that is present in the air, as well as water vapor or any form of moisture. B. State the name of the compound present in rust. This is hydrated iron oxide. C. The table shows three methods used to protect iron from rusting. Choose three of the objects from the box to complete the table. You may only choose an object only once. We have galvanizing. This can be used for a bucket or a car body or even a railway bridge. We have oiling. This can be used for a bicycle chain or a car engine. And we also have painting, and this can be used for a car body or a railway bridge. D. An iron object is coated with zinc to protect it from rusting. This protection continues even if zinc coating becomes scratched. Explain how zinc coating protects the iron from rusting. This is because zinc is going to oxidize and react instead of the iron. Since it's on top, it will react with the oxygen before iron does. And this is only because zinc is much more reactive than iron. When we say reactive, what we mean is that it's going to lose electrons more readily than iron atoms. Question 2. A teacher uses this apparatus to demonstrate the electrolysis of molten zinc chloride. A student records these observations. Crystal of a shiny gray solid formed at one of these electrodes. A pale green substance formed at the other electrode. The lamp goes out after the teacher stops heating zinc chloride. Explain what is meant by the term electrolysis. Here we have the apparatus to demonstrate how electrolysis happens. Electrolysis in general works by passing an electrical current through our electrolyte solution, which is over here. The electrical current causes these ions in the solution to move towards our electrodes being these two over here. And this is where they undergo chemical reactions that result in the release of either positively or negatively charged particles. So if we go to our question with what is meant by the term electrolysis, this is a 2 marker, and it is the decomposition of a compound, and this is using electricity. B. State why graphite is more suitable for the use of electrodes than magnesium in electrolysis. This is because graphite is inert, so it will not react with chlorine, while magnesium will react with it. That's why graphite is much more suitable. C. Which is the correct statement for this electrolysis? It is B. Both products are always going to be elements because what they do is split up the compounds, and in each electrode we get an element that is formed. D. The student writes this ionic half equation for the reaction that forms this pale green substance. Identify 2 mistakes in her half equation. The first thing we can see over here is the 2Cl. We do not write chlorine like this, we write chlorine like this, so that is our first mistake. Our second mistake is that it's not plus 2e minus. Plus 2e minus means that we add 2 electrons. This negative sign just means because electron has a charge that is negative. Instead, it is on the other way because it doesn't make sense that we're adding 2 chlorine that are negative with another negative electron and it equals something that's positive. Instead, it's the other way. It has to be on the right-hand side. E. The lamp goes out after the teacher stops heating the zinc chloride because the electrons are no longer flowing through the wires. Explain why electrons are no longer flowing through the wires. This is because the ions cannot move anymore because the zinc chloride is going to be solidified. So there's not going to be this loss or gain of electrons, which happens, and that's what causes it to have a charge. And this is not going to take place anymore at the electrodes. Question 3. Some metals can be obtained by heating their oxides with carbon. A. The diagram shows a blast furnace used and the produced iron from the iron ore. We have our hot air going in here and we have molten iron coming out. Our raw materials are in the top and all the waste gases go up as well. Give the name of our iron ore. This is hematite. Explain the role of the hot air in our furnace. This is to provide oxygen so that it can able to react with the carbon and oxidize it. Iron oxide can be reduced by carbon. Balance the equation for this reaction. The first thing we do is put out all our elements down from each product and thing. We just list it down here. Now we're going to count how many there is in each type. So over here we have 2 irons, 3 oxygens, and 1 carbon. Here we have 1 iron, we have 1 carbon, and we have 2 oxygens. We can see that our carbons are the exact same, however an oxygen and iron is not balanced. So what we are going to do is we are going to balance our oxygens. We have 3 over here and 2 over here. So what we do is find the lowest common multiple. We can say 6, so that we can have 6 oxygens over here. We have times it by 2, and over here we times it by 3. Now all we have to do is balance all the others. We have 4 irons now. We have 2 over here, and we times it by the 2 that is right next to the iron. So over here we have to put 4, and here we have 3 carbons, so we put 3 over here. IV, limestone is one of the raw materials added to our blast furnace. Explain how limestone removes the impurity silica from the furnace, and you may use equations to help your answer. So limestone is actually calcium carbonate. So what this calcium carbonate does is it decomposes with the heat that is added from the blast furnace, and it forms our CaO, which is calcium oxide. So then this calcium oxide is able to react with our silica, and this is what forms our molten calcium slag. If we put this in equation form, we get our calcium carbonate, and this is going to decompose to make our calcium oxide as well as CO2. And then after that, we get our calcium oxide. We react it with our silica, and this is going to get our calcium silica. We state why aluminium cannot be produced by heating its oxide with carbon. This is because aluminium is much more reactive than carbon. So anything that is on top of carbon in our reactive series cannot be used in this way. Instead, so that we can separate it, we need to use electrolysis. Describe how aluminium is extracted from purified aluminium oxide. We do this by electrolysis. So the first thing we do is that it is dissolved in molten cryolite, and this is so we can bring down the boiling point, because a lot of electricity is needed so that we can supply electrolysis, and this can be very expensive for us. So the walls of the tanks are the negative electrode, and here the aluminium is going to be made. And then the aluminium is going to sink to the bottom and is going to be taped off. Oxygen is also going to be formed at our positive electrode, and it forms and reacts with the graphite ion, and it reacts with the graphite anode so that it can form carbon dioxide. So the anode is going to have to be replaced. We have carbon and graphite, which is our electrodes used. Then our aluminium ions are going to be discharged. 4. Halogens are element in group 7 of the periodic table. The halogen react with the metal to form compounds called halides. Table 1 show all the information about halogens and their halides. AI, predict the physical state of fluorine at room temperature. This is going to be a gas because it has a low boiling point temperature. Predict how the color of astatine at room temperature compares with the color of iodine. This is going to be a much darker gray. B. Each halide in table 1 was dissolved in water to form a solution. A sample of each halogen was then added to some of our halide solutions. Table 2 shows our results. Suggest why there is no reason to add chlorine to lithium chloride solution. Because it's the same halide and halogen, there is going to be no reaction possible. This is because there's no displacement, since halogens cannot react with their own halide ions. Why was there no reaction when iodine was added to sodium bromide solution? This is because iodine is much less reactive than bromine, so that it's not actually able to cause a reaction. Name the substance with the brown color that formed when chlorine was added to potassium iodide solution. This is our iodine. The reaction between bromine and potassium iodide solution is called a displacement reaction. What is the correct description of this reaction? So you can see over here it is displacement, that just the same as saying that one thing is going to displace another. So what happens is that bromine is going to displace iodine. We have bromine, it's going to displace our iodide, it's going to put them out. It's going to be potassium, bromine, and iodine in the side. Complete the chemical equation that shows the reaction between chlorine and potassium bromide solution. Again, this is a displacement reaction, so our chlorine is going to displace our bromine over here, so we're going to have 2 potassium chloride, and our bromine is going to be on the side since it has been displaced, so we just get bromine on the side. Remember, all of our halogens are always going to have that 2 at the bottom. That is how we write it. We do not write it like this. Instead, we write it like this. 5a. Each substance form A ions in the solution. 1 mole of the following substance is dissolved in 1 decimeter cubed of water. Which solution contains the greatest number of ions? This is iron chloride. B. When sodium hydroxide solution is neutralized with an acid, there is a temperature change. A student is given a dilute hydrochloric acid and dilute ethanoic acid in the same concentration. Devise a plan to compare the temperature changes produced when sodium hydroxide is neutralized with each of these 2 acids. First thing we are going to do is always measure a known volume of sodium hydroxide. We need it to be known so that we can later use it in our calculation. Then we add the same volume of each acid. This has to be a control since the only thing we want to see is the difference between the 2 acids, not anything such as volume or concentration. We then stir the mixture to make sure that it's evenly out, and we record our initial and final temperature so that we can figure out what our temperature change is. C. Halogen reacts chlorine to form hydrogen chloride. This reaction is exothermic. Draw and label the reaction profile diagram for this reaction, identifying the activation energy. So because it's exothermic, this means that our reactants are going to have a much higher heat energy in the beginning than our products. This is because when we say it's exothermic, it means all the heat and energy that our reactants originally have is going to be lost to our surroundings. So we can start with our reactants being over here, being much higher, and our products ending up over here. So we need to put in, because we want to label it very clearly stated in our question, we will put our reactants over here and our products on this line over here. Now we need to put in our activation energy. What happens is that we need to give energy to our reactant so that it can be able to break the bond so that we can create this new compound, and then it goes back down. So what does activation energy actually mean? It means that it's the minimum amount of energy required for a reaction to take place between our reactant particles. And in this case, in a diagram, it is this area over here. Our reactants need to go up to this point in our heat energy so that our reaction can actually happen and can actually occur. D. The energy of some bonds are shown in figure 13. Hydrogen reacts with chlorine to form hydrogen chloride. Calculate the energy change for the reaction of 1 mole of hydrogen gas with 1 mole of chlorine gas to form 2 mole of hydrogen chlorine gas. The first thing we do with these type of calculation is draw out the bonds. It may seem like a useless step, but it just makes sure that we don't miscalculate how many bonds are in each one. So we have our hydrogen, and we add this with our chlorine, and this forms 2 HCl. So we have HCl, we have another one of those. Now what we do is we are going to calculate the energy in the bonds in our reactants and our energy bonds in our products. So if we have reactants over here, we have 1 hydrogen bond and 1 chlorine bond. So we have 1 of this and 1 of this. So what we do 4, 3, 6, and we add this by 2, 4, 3. So that's going to equal 6, 7, 9. Now we have 2 hydrogen to chlorine bonds. So we do 4, 3, 2, and we times this by 2 so that we get 864. Now how we calculate our overall energy change is we do reactants and we minus this from products. It's always this way. So we do 679 and we minus this from 864 so that we can get minus 185, and that is our energy, and we just put in our units at the end. Question 6 is about reaction of carboxylic acid. Carboxylic acid reacts with solutions of metal carbonates. Complete the chemical equation for the reaction of ethanoic acid with a potassium carbonate solution. We have our ethanoic acid and we have a potassium carbonate solution. What we are going to get out is have our potassium is going to displace this hydrogen over here because it's more reactive. So we are going to put it over here, and we're going to have 2 because there was 2 in the beginning. Now we are going to always get CO2 and H2O as our byproducts during this reaction. State what you would see in this reaction. We would see effervescence, and what effervescence means is just any bubbling or fizzing that you see in the surface of our reaction. B. The ester ethyl ethanoate can be prepared by reacting ethanol with ethanoic acid. This method for the preparation. So we mix equal amounts of ethanoic acid and ethanol in a boiling tube. Then we add a few drops of concentrated sulfuric acid. Place the boiling tube in a hot water bath for several minutes. First, state the role of concentrated sulfuric acid in this reaction. Their role is so that it's a catalyst, and what a catalyst does is just speeds up the reaction by lowering our activation energy so it happens faster. 2i. Suggest why the mixture is heated in a water bath rather than directly in a Bunsen burner flame. We are using ethanol over here, and ethanol is very flammable, so it might catch fire, which is a safety hazard. So instead we do it with a water bath so that we can really control our temperature and not have that as a possibility. State how you would know that ethyl ethanoate has been formed. Because it is an ester, it's going to have a sweet, kind of a fruity type of smell. And when you get this distinctive smell, you know that an ester has been formed, which is what ethyl ethanoate is. C. Another ester, methylpropanoate, can be prepared by reacting methanol with propanoic acid. Draw the displayed formula of methanol, propanoic acid, and our ester methylpropanoate. First, we have methanol. Meth, this first part means that it has one carbon, so we're going to put our one carbon over here. We know that it is a alcohol, so we're going to put our functional group, which is an OH. Then we need to saturate our carbon. It has 4 electrons, means it needs to bond to 4 things, which is going to be 3 more hydrogens. Now we have propanoic acid. Prop, this thing means that it has 3 carbons, so we're going to put 3 carbons first. We know that the functional group of a carboxylic acid, which propanoic acid is going to be a double bond O with an OH, and now we just fill in the rest with hydrogen, making sure that each carbon is bonded by 4 different things. Methylpropanoate comes by mixing methanol and propanoic acid, so we can use our previous diagram. So when they react, we get water, and water is H2O. So what we have to do is try and find a way to get this out of these two. So they take this hydrogen over here, so now we need an H and an O, and we take this over here, and then we add it together where this C is now going to be reacted with this O over here. So we have CH, and we have our O. This H is gone because it's gone to form our water, because this is a condensation reaction where water is formed. And then this is going to be bonded over here to our C, and this has a double bond O on top. And then we just continue it, basically just doing it in the opposite way. So you can see that we have our methyl, this meth is over here, and it's with this O, and we have prop, which is our 3 over here. So we have this O, which kind of separates both of them. And as soon as you see this over here, where it is a C double bonded to one O and singly bonded to another, we know it's an ester because that is its functional group. Give the name of the other product formed in this reaction. We already went through this. This is water. Give one use of esters. Because we said that it had this distinctive smell, which is kind of fruity, it is a nice smell. This can be used in perfumes or even food flavoring, especially in cosmetics, soaps, even making detergents or solvents, paints as well. This is all uses of ester. 7. Ethanol is a member of a homologous series of alcohol. Give 2 characteristics of a homologous series. There's actually 5 different features that you can choose from. First of all, it has a same general formula. The second is that each member differs by the next by CH2. They also all have the same functional group. They have all similar chemical properties, which means its reaction, they react the same. Also, the last one is that there's going to be a trend or a steady increase within their physical properties, such as their boiling point. B. When ethanol is heated with potassium dichromate and one other reagent, the ethanol is oxidized to ethanoic acid. Give the formula of the other reagent. This is sulfuric acid. State the color change that occurs during this oxidation reaction. What happens is that it goes from orange and it goes to green once it is oxidized. 8. The industrial production of sulfuric acid involves several steps. One of these steps is that the reaction of sulfur dioxide with oxygen to form sulfur trioxide. This reaction to produce sulfur trioxide reaches an equilibrium. The forward reaction is exothermic, and the rate of attainment of equilibrium and equilibrium yield of sulfur trioxide is of course affected by pressure and temperature. A manufacturer considered between two sets of conditions, A and B, for this reaction. In each case, sulfur dioxide is mixed with excess oxygen. The manufacturer changed the temperature and the pressure and only used catalysts in B. The set of conditions in A and B are shown in figure 7. The manufacturer chooses set B rather than set conditions of A. Explain by considering the effect of changing the condition on the rate of attainment of equilibrium, the equilibrium yield of sulfur trioxide, why the manufacturer chose set B rather than condition set of A. We are always going to be focusing on 3 different aspects. We focus on our temperature, pressure, and catalyst. So first of all, we can see over here that temperature is used at much higher at A. So we can say because a much higher use of temperature is shown at A, equilibrium will be reached much faster in set A. This is because higher temperature means more frequent collisions between the molecules because they have more energy. However, because it is an exothermic, increasing temperature, whenever you increase the temperature in equilibrium, it is always going to favor the endothermic side because of Le Chatelier principle, that it wants to counteract the change that has just been happened. So to decrease the temperature after it's been increased, they want to favor the endothermic side. And the endothermic side in this case is our backward reaction. So our yield is going to be much lower, which is why set A isn't very good. Instead, we want to decrease the temperature like how in B, since it will increase the equilibrium yield. However, the system will take longer to reach equilibrium. So this means the temperature chosen is for the optimum condition. We can say again, if we're talking about A, is that the yield lowers as the forward reaction is exothermic, since high temperatures are always going to favor the backward reaction, which is a endothermic, so equilibrium will be reached faster. Now that we talked about temperature, with temperature we will favor B because in these cases a yield is always going to be more important than temperature, especially since a catalyst is used in B and it's not used in A. So because our catalyst, what a catalyst does is that it causes the equilibrium to be reached faster. It doesn't affect the equilibrium position at all, and catalyst never affects the yield. However, a catalyst does increase the rate of both forward and backwards reaction. So because we're using a catalyst in B, it reduces the need for our high temperature, so we get more yield as well as a higher rate of reaction which is needed, so our temperature doesn't become as important anymore. Now the only thing we need to talk about is pressure. So we have more pressure in 4 and we have 2 in A. How we figure out which way it's going to go if pressure is lower or higher is we calculate the moles of the reactants and calculate the moles of the products. So over here we have 2 and 1, 3, and here we have 2. In set A, we have a lower pressure, so what it's going to favor? It's going to favor the one with more moles. This means it's forwarding the backwards reaction, which is something that we do not want because it's going to decrease our yield. Instead, we want more pressure, so if we increase the pressure, it's going to favor the forward reaction because it favors the reaction that has less moles, which is the forward reaction in this case. Also, higher pressure causes molecules to be closer together, so there's more frequent collisions. So the yield will be higher because products occupy a smaller volume than it does in reactants for set B. So that's why set B is much more favored, and that's why the manufacturer chooses. This is just a more condensed version of what I was saying. It is only 6 marks, so you don't really need to say all this information. I recommend that you structure this so that it says, what is the effect on the yield? Why exactly is that? And remember, when you talk about equilibrium, you don't only talk about its effect on the yield, you also talk about the rate of reaction. So kinetics and things comes into play. Question 9. Acid ingestion is caused by having too many hydrochloric acid in the stomach. A suspension of magnesium hydroxide in the water can be used to cure this acid ingestion. The equation for the reaction between magnesium hydroxide and hydrochloric acid is that a student investigates how much magnesium hydroxide is needed to neutralize 100 centimeters cubed of hydrochloric acid with a concentration of 0.0968. He uses 0.9 grams of magnesium hydroxide to neutralize this hydrochloric acid. Calculate the amount in moles of HCl in hydrochloric acid. So the equation we are going to use is that moles, which is shown as N, is the same as concentration, and we times this by volume. So we have our volume over here. However, our volume here is in centimeters cubed, what we want, we always work with volume in the units decimeters cubed. This is because it is the standard unit that all scientists use, so if you don't use it in this, you will lose marks. How we convert centimeter cubed to decimeter cubed is we divide by 1,000. So 100 divided by 1,000 will be times 0.1, and we have our concentration over here, so we do 0.0968, and we get the answer of 0.00968. B. Calculate the amount in moles of Mg0H2 used by the student where the MR is 58. So what we are going to use is we're going to use N, and that equals grams over MR. We have our MR, which is 58, and they already told us over here that we use 0.9 grams, so we put 0.29. We just divide it by each other and we get 0.005. Remember to always put the equation you're using just so that the examiners make sure that you know what you're doing, and if in case something goes wrong when calculating or in your calculator, you still get the mark because you understand what formula you had to use. Explain whether the student used the right amount of magnesium hydroxide to neutralize the hydrochloric acid. The answer is yes, he did use the right amount of magnesium hydroxide, and this is going to be because we can see over here that 1 mole of magnesium hydroxide is reacted by 2 HCl. So we know that the ratio is 2 to 1. So we know our moles for HCl, which we found over here, is 0.00968. The minimum that we need is going to be whatever we divided by 2 because of the ratio. So it's going to need 0.00484 so that it can actually react. Here we calculated that there's 0.05, so that's actually much more than what we have over here. So there is enough so that this is the right amount of magnesium hydroxide to neutralize our hydrochloric acid. Question 10. A sample of rock salt contains the mixture of sodium chloride and some insoluble substances. The rock salt is added to the water and the mixture is stirred. The mixture is then filtrated to obtain the filtrate of sodium chloride solution. Draw a label diagram of the apparatus that is used to filter the mixture and collect the sodium chloride solution. So how we do this is that we know that it's filtered, so the first thing we are going to do is we are going to draw in our conical flask, which looks something like this. Then we are going to have our filter funnel, which looks something like this. And of course, with every filter funnel, you need to always make sure that you draw your filter. Now we need to label it. So we just label this as our conical flask. We have this as our filter funnel. We have here as our filter paper. Of course, in the real exam, do this using a ruler. Describe how a sample of pure dry sodium chloride crystals can be obtained from our filtrate. The first thing you do is you're going to heat the solution to concentrate it, and then we are going to leave the solution in a warm place, such as a warm oven, and then you can either scrape the crystal or pat dry between the filter paper, or you can just filter off the crystal by using decant liquid from the crystals. Question 11. This question is about gases in the air. The pie chart represents the percentage of gas in dry, unpolluted air. Gases with percentage of less than 1% of air are called trace gases. So we have gas C, which kind of dominates the pie chart, and we have trace gases over here. Which of these are gas C? This is nitrogen, because in our atmosphere, nitrogen is the one that occupies most of it. It's around 78%. Which of these approximate percentage of oxygen in dry, unpolluted air? This is 21%, and this is our white part over here. B. One of the traces in gases is carbon dioxide. Identify 2 reactions that produce carbon dioxide by placing a tick in these 2 boxes. We have the complete combustion of alkane that always produces carbon dioxide as a byproduct. And we have the thermal decomposition of copper carbonate. This carbonate over here already shows that carbon dioxide is part of it. Name the environmental problem that is caused by the percentage of carbon dioxide increasing in the atmosphere. This is global warming and can also be climate change. Name the trace gas with the highest percentage in the dry, unpolluted air. This is argon. Rainwater is acidic because carbon dioxide dissolves in water to form carbonic acid. Acid rain is more acidic than rainwater because acid pollutant gas also dissolved in this water. Give the name of acid that forms when nitrogen dioxide dissolves in the water. This is called nitric acid. Name another polluting gas that also forms acid rain. This is sulfur dioxide. 12. This is a recipe for making Irish soda bread. Add 170 grams of whole wheat flour and 170 grams of plain flours, 10 grams of salt, and 10.5 grams of bicarbonate of soda to a bowl and stir. Now we pour 290 centimeters cubed of buttermilk and stir quickly to form a soft dough. Form the dough into a round bowl and slightly flatten it and cut across in the top and bake for 30 minutes in an oven of 200 Celsius. When sodium hydrogen carbonate is heated, carbon dioxide gas is formed. Calculate in mass in grams the carbon dioxide that will be produced by completely decomposing 10.5 grams of sodium hydrogen carbonate. So first we are going to find the moles of sodium hydrogen carbonate, and how we do that is we do our grams over our MR. So we already have here, we have 10.5, so we do 10.5 and we divide this by our MR, which is 8.4, so that equals 0.125. Now we are going to times this. If we just put this on the other way, to find grams, we do moles times MR, so that we can find it for carbon dioxide. We already have our MR of this, which is 44. You can find that in the periodic table. So we'll do 0.125 times by 44, and we get 2.75. So you do 2.75, and you are going to divide this by 44, which is, so it's grams divided by MR, and you get 0.0625. This is so we can find out our moles. And what you do then is you times it by our volume. So you do 24000, and our answer would be 1,500. And that's the end of our predicted paper. Please let me know if you have any questions, whether it's to do with predicted paper or content in general. I'm more than happy to help. Thank you so much. Good luck on your exam.